Of what the universe is made of. The universe is made up of matter. Now, inside matter are small, minute particles called atoms. When we view deeper into atoms, we find the nucleus orbited by electrons. Now, inside the nucleus are substances called the protons and the neutrons. But are they the smallest particles existing? More than 50 years ago, it was discovered that protons are made up of tiny particles called quarks. And this led to the discovery of the Standard Model. The Standard Model is made up of 12 particles, and these are grouped into three families. We have the quarks, the leptons, and the bosons. Now, quarks and leptons are collectively called fermions. Now, there are six flavors of quarks, and I'm sure you must be wondering why they are called flavors. So we have the up quark, the down quark, the top quark, the bottom quark, the charm quark, and the strange quark. Let's take the proton for example. The proton is made up of three quarks, and this is what makes it a baryon. It consists of two up quarks and then one down quark, and that is why it has a charge of +1. Now, these quarks have a color of either red, blue, or green, and the exchange of these color charges between them by force carriers called gluons is what creates the strong nuclear force. This force overcomes the electromagnetic force of protons, and that is why they stick together rather than repel. Now, when you try to kick a quark away from a baryon, it forms a new quark and an antiquark, and this is what we call a meson. And the exchange of mesons between protons and then neutrons is what also causes them to stick together. Now, you have the electroweak theory, and it constitutes electromagnetic force and then the weak force. Now, electromagnetic force. Electromagnetic force is created when there's the exchange of virtual photons between charged particles. The weak forces are formed equal. We have the Higgs particles, and these are responsible for the mass of elementary particles. Now, onto the last force carriers, the W bosons and the Z bosons, and these are responsible for weak forces. That will be something like this. This is exactly how unstable atoms feel, and they try to gain stability by either changing their neutrons to protons or their protons to neutrons. And this is carried out by decay processes known as either beta minus or beta plus. Now, these decay processes help hydrogen atoms in the sun to change to helium atoms, and without these, the Earth would be very cold. And this concept is of quarks and messenger particles.